Okay, so now we want to think about the domain and range of the sine and cosine. So here's our quadrant system. Here's this unit circle. Okay, and remember when we have the sine, we'll talk about sine first. The sine is of an angle t. So t is what you're measuring, what you're sweeping out when you're going around the circle. It's the angle. This is an angle. You can keep going around the circle. Okay, the angle is the input. Okay, so t, you could have it be, any angle. It could be in radians, right? So you can just go this way, or you can even go that way around the circle, right? So the input is all real numbers. Okay? But what's the output? So the sine of t equals, if you remember, it equals y. So what is the output? Like when you're, when you have points around this circle, what is the y value going between? Well, it's got to be between 1 and -1, right? So your range, I'm sorry, I didn't write that this was the domain here. So the domain for sine is -infinity to infinity, but the range is -1 to 1. Okay? So think all those points that you have on the circle, they all have a y value that is between -1 and 1. Okay? Now for cosine of t is equal to x, right? So again, your input could be any real number. So the domain could have any angle, -infinity to infinity. But the range, well, the range is going to be along the x-axis, right? So it's along the x-axis. The lowest I go is -1, the highest I go is 1. And so the range for cosine is -1 to 1. So think about inputs and outputs, domain and range. The input is an angle. And that angle could be positive or negative, and it can have any radian measure you want between -infinity and infinity. The output, that's the range, and that comes off the unit circle. Our highest and lowest values for x are -infinity and infinity, and for y, positive infinity, or negative, I'm saying it wrong. Okay, our range, our outputs are for x between -1 and 1, and our outputs for y are between -1 and 1. Okay? All right. I don't have anything here that says output, but it's between -1 and 1. Okay.